This video discusses about arithmetic mean. The mean of a set of quantitative data is equal to the sum of the values divided by the number of values contained in the data set. The sum of the values is denoted by sigma x. Sample size is denoted by n. Sample mean, denoted by x bar, is equal to sum of x divided by n. Let's us look at an example. You will find that the sum of all the values, sigma x equal to 1406. Sample size n is 7. Sample mean, x bar is equal to 200.86. Hence, the mean weekly expenditure for each family is Rm 200.86. Let's calculate the sample mean from a frequency table. From the frequency column, we get the sample size n to be equal to 56. We get this by adding all the frequency values. For sum of the values, we need to multiply each value with its frequency to get the subtotal. Hence, the first subtotal is 0 multiplied by 6, which is equal to 0. 1 multiplied by 13, which is equal to 13. 2 multiplied by 10, which is equal to 20. 3 multiplied by 15, which is equal to 45. 4 multiplied by 9, which is equal to 36, and 5 multiplied by 3, which is equal to 15. The total sum of the values will be 0 plus 13 plus 20 plus 45 plus 36 plus 15, which is equal 129. Therefore the sample mean x bar is equal to 129 divided by 56, which is equal to 2.3036. Note that, we can use notation x for values, and f for frequency. The subtotal column is denoted by fx. Note that the grand total can be written as sigma fx. Hence, for a frequency table, the formula for sample mean, x bar, is equal to sigma fx divided by n. Find the sample mean for the following frequency table. Here we need to calculate the midpoint for each class interval. The midpoint is denoted by x. The midpoint for a class interval is calculated by taking the lower limit plus the upper limit divided by 2. For the first class interval, the midpoint is 20 plus 25 divided by 2, which is equal to 22.5. Since the class width is 5 for all class interval, the rest of the midpoint can be calculated by adding 5 from the previous class midpoint. So, the midpoint for the second interval is 22.5 plus 5, which is equal to 27.5. The midpoint for the third class interval is 27.5 plus 5, which is equal to 32.5. The midpoint for the fourth class interval is 32.5 plus 5, which is equal to 37.5. The midpoint for the fifth class interval is 37.5 plus 5, which is equal to 42.5. And the midpoint for the sixth class interval is 42.5 plus 5, which is equal to 47.5. You can verify that sigma fx is equal to 1817.5 and the sample size, n, equals 51. X bar is equal to 1817.5 divided by 51, which is equal to 35.6373. Calculate the sample mean from the histogram. You can verify that sigma fx is equal to 2276.5 and sample size n equals 37. X bar is equal to 61.5270. We can mark the mean value on the histogram. This problem reads as follows. The following are 4 subjects taken by a student. The credit hours and the score for each subject are also shown. Find the mean score for each subject per credit hour. Suppose we calculate the mean score without taking into account the credit hours. This type of mean is called unweighted mean. We will get the unweighted mean equals to 90 plus 70 plus 85 plus 63 divided by 4, which is equal to 308 divided by 4, which is equal to 77. Taking the credit hours into account, the mean that we are about to calculate is known as the weighted mean. Here, the credit hours is treated as the frequency, and the scores is x. Hence n is equal to 11 and sigma fx is equal to 807. The weighted mean is equal to 807 divided by 11, which is equal to 73.3636. The unweighted mean that we calculated area is not the right mean. The true mean for this problem is the weighted mean, which gives a score of 73.3636 per credit hours. Thank you for watching.